This is 1.5C. I'm on page 124. We just got done with example 2, or example 4 on the storage area. Now we're going into functions defined piecewise. Piecewise is a little bit tricky. We're going to do a few of these examples, and I gave you some in the homework to try to get a hold of what's going on here. I say tricky, but once you kind of understand what's going on here, they aren't too terribly bad. Now notice they don't really give you any explanation. They just start right in on examples, so that's what we're going to do here. And I'll explain what the whole piecewise thing is as we get going. Not really sure why they call it piecewise, but they do. So let's look at example 5 here. Okay, well let's look and see what this actually means, what they're saying here. They're giving us a couple options. They're saying that x can be really any number, x can be smaller than 3, x can be 3, and x can be greater than 3. So really x is any real number out there. And so what the piecewise says is, for any number where x is less than 3, we use this equation to find our y value. So if we have our graph, and I'm just going to draw one here real quick, and I say that my x value is going to be less than 3. Well, let's see what happens if I put, if x is less than 3. So I'm going to put in let's just put in 2. Okay, so when x is 2, I'm going to use this equation, because it says whenever x is less than 3, we use that equation. So I get 1/3 times 2, so I get 2/3 plus 3 for my y value, or 3 2/3. So I'm going to have x is 2, y is going to be up here somewhere. Okay? And I'm just going to keep putting numbers in whenever x is less than 3. And I'll end up getting a graph that looks kind of like that. Well, it'll be a straight line. For this bottom one, it says, okay, so what if my x is not less than 3? What if my x is bigger than 3 or equal to 3? Well, I use this equation. So let's say that my x is 3. Then my y value is going to be the opposite of 3. So I'm going to end up getting a graph that looks like closed circle because of the less or the greater than or equal to sign. And, and notice this one up here, it's supposed to be an open circle because it does not include 3 up here. And that's a piecewise function. The graph, I don't know, is broken into 2 pieces. So depending on what we're looking at, that's what we get. And so you're going to notice with most of these piecewise functions, you're going to get 2 pieces of a graph, basically. Okay? And one thing to notice, this is a function because this vertical line goes through those 2 points. Now again, it goes through those 2 points, but remember this one is an open circle, so that 3 is not included, where this one is a closed circle, so it is included. So it still only goes through 1 point of the graph. So that's that piecewise function. Let's try the next one, example 6, and that has 3 points to it. And so let's go ahead and draw that out. So notice this piecewise function. It says when I have a number that is less than or equal to 0, so really 0 and any negative number, my y value is automatically 4. Does not matter what number this is, as long as it's 0 or smaller, my y value is going to be 4. So if I were to graph this, and I would get for a graph 0 and everything this way. My y value will always be 4. That distance will always be 4 whenever x is less than or equal to 0. Okay, the second one says that whenever my x is bigger than 0, so it doesn't include 0, so it's bigger than 0, but it's less than or equal to 2, my y value is going to be 4 minus x squared. So for instance, if my x value were 1, that's between 0 and 2, and I put it in here, 4 minus 1 is 3. So that means if my x value is 1, my y value is going to be 3. And that's going to put a point right there. Let's say that my point is at 0. Okay, let's say I make x 0. Okay, it has to be bigger than that, but I can at least start at 0. So if I put a 0 in there, I got 4. So I would have an open circle here, but on my other part of my function here, I had a closed circle. So even though this one is an open circle, the closed circle is going to mean it's pretty much closed, because even though this part of the graph doesn't include 0, this part of the graph does include 0. So when I put all the graphs together, I end up with it covering over 0. So that'll come down like that, and since this includes 2, it's a closed circle. So then, for x is greater than 2, so again it does not include 2, so it's an open circle, but since this top one includes 2, it will appear as a closed circle. So any number that is, greater than 2. Alright, let's put some numbers in here. So we put in an x and a y, and we put in 2. What do we get? We get 4 minus 6 is negative 2. So we get an open circle at negative 2. Okay, so I was saying we start there, but I wasn't plugging a number in this third inequality yet. So ignore what I said about that earlier as far as this being open and closed at the same time, like this one was, because it's not. It just ends there with a closed circle. And now we start on this one here. So if we put in 3, we get 0. So over 1, 2, 3, we get a 0 there. So we end up getting here a graph that goes that way. So this whole thing is our piecewise function of that function right there, which is very similar to the one on the bottom of page 125. So let's look at this piecewise function. We've only got 2 parts to this. We've got when x is not equal to negative 2, so that means when x is any number but negative 2, we plug it in here and get our y value out. For x is equal to negative 2, it's going to spit out a 3. So let's do this bottom one first, since it's just the easiest. So x is negative 2, y is going to be 3, closed circle, we're done. Now let's look at the top one. Whenever x is not negative 2, we're going to plug it in here and get a y value. Okay? So let's say that x is negative 2, and let's plug that negative 2 in here and see what we get. Because that is, what we're getting here is, we're going to get a straight line. And if x is, well, let's just do it with any numbers and get our straight line and then go from there. Let's plug 2 in. Okay, we plug 2 in and we get 0 for our y value. Okay, let's make it black. Alright, let's plug negative 2 in. We also get let's plug 0 in. We're going to get a negative 2 there. 0 minus 4 is negative 4. 0 plus 2 is 2. Negative 4 over 2 gives us negative 2. And let's draw our line. Okay. But when I draw that line, notice I also included x equals negative 2 in my answer right here. What did I say about negative 2? It can't be part of the answer. So what I have to do here is I have to put an open circle here to say that this graph includes all numbers here and all numbers here, except for when x is -2, because when x is -2, I get this number. So it's kind of like I took the point out of here and moved it up here, because when x is -2, it's 3. All other numbers are on this line right there. Okay, so when you're doing that, just as a reminder, we have a hole down here is what they call it, and it's indicated by that open dot. So the last part of this is the greatest integer function, bottom of page 126. And I'm not going to give you any problems on this. I am just going to kind of give you an idea of what that is. It's represented by f of x equals, and it's just kind of a weird symbol. Don't even know if it has a name. It looks like that. And the definition is the greatest integer less than or equal to x. Okay, so if I give you some pairings, if I give you an x value of -4, -3.6, this is at the bottom of page 126. I don't like them using these negative numbers as our first example, but let's do it anyway, I guess, see if I can explain it. The greatest integer function says that when we put in an input a number, -4 or -3.6 or -3 1/4 or whatever we put, the y value that it's going to kick out will always be an integer, so a counting number, either the same as the input or less than the input. So this number is greater than this. So this number is either equal to the input or it's less than the input. So if I put -3.6, it's going to spit out the next integer. -3 1/4, it's going to spit out the next integer, the next counting number that's smaller than what we put in. So let's look at the third one over. That one is a lot better to put in because it's positive. Well, in fact, let's do the fourth one. 2.1, 2 3/4. Okay, so the greatest integer is going to be a 2, because that number is the biggest number, the biggest integer that's either equal to the input or less than the input. So 2.1, it's going to spit out a 2 no matter what. It doesn't matter what the equation is, doesn't matter what of anything. We put in a 2.1, it's going to spit out 2. If we put in a 2 3/4, it's going to spit out a 2. If we put in 2 7/8, it's going to spit out a 2. But if this became a 3, it's going to spit out a 3 because it has to put out a number that is either equal to this number or less than this number. So since it's equal, it works. And then if I put in, let's say, a 3.5, it again is going to spit out a 3 because the 3 is the number less than the integer less than 3.5, the greatest number less than 3.5. So it can be a little bit confusing because you can plug in only numbers that are 2 up to 2.99999, whatever, and the output is going to be the first integer, the greatest integer, less than whatever your input is, or equal to what your input is. So anytime this says 2, your greatest integer function is going to be 2. As long as there's a 3 in front, doesn't matter what the decimal is or fraction after, the greatest integer is going to be the 3. So I don't know if that helps or not. When you get into negatives, kind of makes it a little bit different because this number is the greatest integer that is smaller than or equal to these 3 here. So does make it a little bit tricky when you're dealing with negative numbers. So that's pretty much what the greatest integer function is. You will see this later in the course, and we'll go into more detail about how to do it. And when you're in calculus, you will go into it a little bit more because it's one of those piecewise functions that you'll use.